All right, everybody. So today you should be taking your M4T2 assessment. The link is on the plan book right below this. If you're an honor student, make sure that you click on the link that is on the bottom, and standard ones, you'll just click on the link that's on the top. Just make sure you're clicking on the right links. I'm going to be posting the answers to this review in this video. If you have questions about how I'm getting those answers, there's a couple that I'll probably go through with y'all that I know a few of you would probably struggle with. But for the most part, I will probably just be writing down the answers. And if you're struggling to figure out how I got those answers, you can join the Zoom call that I will have open for the first 15 minutes of class before you should be taking your test. All right, so, and I'm going to give a little helpful hints along the way. So for number one, what you should have done was gone to your calculator, gone to mode, clicked all the way down to real, and then clicked over to where A plus BI was highlighted and click enter, and then click clear. And then you can do second square root of negative 64, and it will give you that 8i is the answer there, and that was all that you had to do. So the answer for number one is that 8i. For number two, the square root of 75 is not perfect, so what you're looking at here is the square root of negative 1 times the square root of 75. That negative 1 is where we get the I from. 75, you have to make a factor tree for. I did 5 times 15, and 15 was 5 times 3. So 5 times 5 times 3, pull out a 5, left with a 3. So your final answer is 5i, square root of 3. 2, 4, 5, and 6. Again, you can type those exactly in the calculator as you see them. Your I button is if you hit second decimal, the I button will pop up. So for number 3, I got 4 plus 5i. For number 4, I got negative 6 minus 8i. For number 5, I got 7 plus 4i. And for 6, I got negative 26. So the really important things is that if you were doing these by hand, that I squared equals negative 1. And then as we went over earlier, the square root of negative 1 equals I. So you're going to interchange those. For number 7, and my question that doesn't have an answer to it, or a number to it, for number 7, hopefully you got that x was equal to plus or minus 5i. This equation right here is not factorable. You can solve it by either doing the square root method or the quadratic formula. I'm going to solve it doing the square root method. So if you're looking at it, excuse me, sorry, 0 equals x squared plus 25. If you subtract 25 from both sides, you're left with 25. Negative 25 equals x squared. Take the square root of both sides. That's where you get the plus or minus 5i equals x. And I just flipped it around down there. For this second, determine the roots of each equation, because your roots are, I forgot to cover this, your solutions, zeros, x-intercepts. So find your solutions to the second one. This is, again, not factorable. So for this one, you do have to do the quadratic formula, or you could do completing the square, but I like the quadratic formula more. So A is 1, B is negative 1, and C is 7. So you get x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So then hopefully you got 1 plus or minus the square root of negative 27 divided by 2. The square root of negative 27 is not a perfect square root, so 27, I believe I divided by 3 and got 9, and then 3 and 3. So I also recognize the square root of 9 is 3, so what you're looking at is x equals 1 plus or minus 3i square root of 3 divided by 2 would be your final answer here. All right, so determining the solution set for the quadratic inequality. So this was those ones where we would solve it for our x-intercepts, and then we would put those on a number line, pick a number to the left, pick a number in the middle, and pick a number to the right. So I recognize that this was easily factorable because the factors of 7 are 1 and 7, and we're negative 7. So one of them has to be negative and wanting to add to get to negative 6. So negative 7 and 1. So x plus 1, x minus 7 equals 0. Because remember, we changed that sign to an equals to be able to solve for these. You'll get x plus 1 equals 0, x minus 7 equals 0, x equals negative 1, and x equals positive 7. So at this point is where you would make your number line, which I'm going to do over here to the left. And you're looking at negative 1 and 7 are the zeros of this parabola. Now, what I would tell you to do is pick a number to the left, pick a number in between, which I would choose 0, and then pick a number to the right. When I plugged these in, I got 9, negative 7, and 9. And then you go back to the original equation. So these are less than or equal to 0. And do remember with these, you do have to be set equal to 0 to be able to solve it for your x's. So say that this was not set equal to 0. Say it was set equal to like, we'll make it an 8. Whenever I came down here and got it set equal to 0, you would still use this sign, but you would want to put it equal to 0 for those solutions. I got that this was false, and this was true. So that means that my parabola is less than 0 between negative 1 and 7. So my answer would be negative 1 is less than or equal to x, and x is less than or equal to 7. A little trick for on the test, if you forget how to do this, is at this, once you're equal to 0 with that sign, I am comfortable with y'all coming and putting this in the calculator. Let's see if I can somehow see both these at the same time. So you would come over here and you would type x squared minus 6x minus 7 and click graph. If you do not see this graph, click zoom 6 and it will bring you back to this viewing window. And here you can confirm your zeros too, negative 1 and 7. So those are true. And at that point, I am okay with y'all just going over here and sketching this graph out. But then at that point, you have to look at your original equation. We want it was less than or equal to 0. So that was when it was between negative 1 and 7. So you would not have to plug in these values. All right, let's go ahead and flip it over. So solving systems of equation algebraically over the set of real numbers. So what you want to do here is you want to substitute one equation into the other. So you're going to put x squared plus 3x plus 7 equals negative x squared minus 3x plus 3. And then you're going to solve for your x's. I used the quadratic formula for this once I got this set equal to 0. And I got one of my x's was x equals negative 1 and x equals negative 2. I then plugged those in to get y equals 5 and y equals 5. So once you get your x values, you have to plug those x values back into one of these equations where there's x's to get your y values. But so your solutions to the system were negative 1 and 5 and negative 2 and 5. On 10, 11, and 12, all you have to do is look at these graphs and determine the solutions. That's where the two graphs intercept each other and give me the points. So negative 1, 0, 1, negative 4. Make sure you're looking to see what the lines are kind of by. So this was obviously by ones. Over here it's not given to you, but we are going to assume it's by ones. So 1, negative 3, and negative 3, 5. That's that negative 3, 5, and that's that 1, negative 3. So down here, number 12 is where you have to look and see what the lines are counting by, because this is negative 4 right here. This line right here is negative 4, so that means this line right here is negative 2. So that point right there is negative 3, 2, because again, this is 2, 4, 6, 8. So make sure you are looking at what the axis is increasing by or decreasing by. All right, so number 13, it just says how many solutions are there for the following system of equations. If I was you, what I would do is I would go to my calculator. I would go to my y equals. I would type in x squared minus 5x plus 3. And then I would type in x minus 6. I would graph that, and you can see right there that there is one solution. If you did want to solve it to determine that there was one solution, you do what we did earlier and you set them equal to each other. So 5x plus 3 equals x minus 6. Get it set equal to 0. You either do the quadratic formula is probably what I would do, and you get 3, negative 3 for your final answer. All right, so for 14, all it's asking here is to tell how many solutions this system has. So you can look at it and count 1, 2. So this has 2 solutions. All right, down here on number 15, what are the solutions to this system? Again, you're doing what we've done for all the other ones that you're asking for solutions. So you're going to do negative x squared plus 4 equals 2x plus 1. Get that set equal to 0. When I did that, I got 0 equals x squared plus 2x minus 3. I then factored it to get that x equals negative 3 and x equals positive 1. I plugged those back into my linear equation because that's always easier, in my opinion. Got negative 5 and positive 3. So my solutions were negative 3, negative 5, and 1, 3. All right, so for number 16, this is a quadratic regression. And this was what we did on the last day that we were in school. So I will go through this one kind of step by step with y'all because I know that I think it was 7th period, didn't really get the notes from me in class. But so you're going to click on Stat, click Enter on Edit. If you already have values in your table, I would just click up and click Clear and click back down and it should disappear. So click up, click Clear, click down. Then you need to type in these values exactly as you see them. So 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And then you're going to click over to L2 because that's where you're going to put in the next column of data. So 315 or 215, sorry. 520, 725, 865, 955, and 207. And so once you get all those values in, you then click Stat again, click over to Calculate. And because these numbers go up and then go back down, that's telling you that it's going to be a quadratic regression. So you'll click 5, click Enter, 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 Enter. And then at this point, it gives you, let me try to set these up next to each other. At this point, it gives you an A, B, C, and an R squared value. You want your R squared value to be as close to 1 as you can get. So this equation does not hit exactly every single point, but it hits majority of the points. So then we know, then we're looking at y equals negative 3.581 x squared plus 107.52, we'll call it 1, x plus 211.200, and we'll call it 66. And so that would be your quadratic regression equation for that set of data. Whenever you come down here to 17, it's asking for this quadratic regression equation is modeled down here on this scatter plot and predicted value for when f of x equals 6. So whenever we're talking about f of x equals 6, what that means is y equals 6. So we want to go to where our y value is 6 on this graph. And I'm going to zoom in really well so we can see exactly what values we're at. I'm probably actually going to go and uncircle them. So again, you got to look down here at the bottom to see how this graph is increasing. So this round right here is 0.25. This is 0.5, and this is 0.75, and then 1. So you would get that x equals 0.4 for that first point because it's just below 0.5. And for that second point, again, so that's a half right there. So this will be 0.75 here. And it's hitting that almost exactly. So x will equal 2.75 would be your two solutions there. All right, and we'll go ahead and flip over to the back page. So the scatter plot represents this certain animal species in the year since 2005. What does the y-intercept represent in this situation? So you can look over here that your y-intercept is at 0, 500, and I can tell that because we're looking at 1,000, and half of 1,000 is 500. So, and at this point, I need to look and see how my axes are labeled to determine what this means. So years since 2005, and we're at 0. So that means that in 2005, the population of this animal was 500. Whoa. All right, and then whenever you come down here to 19 and 20, these are matrices that you just are going to type straight into your calculator. I will go over how to set one of them up with you, and then the other one I believe you should be good on. So you're going to have all your x's in this first column. So 2, -1, 5. The second one will be your y. So 5, 4. You do not have a y in this bottom equation, so you have a 0. Your z's will be 1, 3, -2, -12, -4, -13. The steps are given to you below on how to type these into a calculator, but I'll go over with you again. So you're going to want to click second, x to the negative first, and it pulls up the matrices. So you're going to want to click over to edit, click enter. We are looking at a 3 by 4 matrix here, and we're going to input those values as we see them. So 2, 5, 1, -12, -1, 4, 3, -4, 5, 0, -2. Oh, and so you have to be very careful on these as well, because see that I did 50 here? It was supposed to be 5, 0, -2, -13. And then I'm going to come over here and look at my points that I was supposed to have in and double check that I did that correctly. So then at this point, you have to hit second mode, which will quit and take you back to that original home screen. You're going to want to click second to the x to the negative first again. Click over to math. And you are going to want to go down until you see RREF, which is that B. Click enter. Click second x to the negative first. Oops, not that one. Click enter, enter, and the matrice will pull up. So what that matrix is telling us is that x equals -3, y equals -1, and z equals -1. You would do that all over again for the matrix over here, and hopefully you got that x equals 1, y equals 1, and z equals 4. All right, so those are the answers to the review. You can use this review on your test. I actually strongly recommend that you do. If you have any questions before you start your test, join my Zoom call. The link is above the plan book on Kidim. All right, good luck on your test.